Have you ever wondered what it would take to build a single brain that could power literally any robot you could think of? From a little-wheeled rover to a four-legged robotic dog? Well, today, we're going to dive into a super ambitious project called the Kinetic Core. It's aiming to be the universal mind and nervous system for pretty much any robot.
And that really is the huge question driving this whole thing. What if one single brain could power any robot, no matter its shape or what it's supposed to do? That's the goal here. Creating a system that's form-factor agnostic. That just means the same core software could run a drone, a robotic arm, or a delivery bot. It would completely change how we design and build robots from the ground up.
And that vision, that big idea, it has a name, the Kinetic Core. The best way to think about it is as a single, modular piece of software architecture that's designed to intelligently control any kind of robot you can dream up.
See, the whole point is to handle all the messy, complicated, low-level hardware stuff for the developer. So instead of having to program every single joint and motor from scratch for every new robot they build, they get this solid, reliable foundation to build on. This makes development so much faster, and it lets creators focus on the robot's purpose, not just the nitty-gritty mechanics of how it moves.
Okay, so how does it actually work?
Let's pop the hood and look inside the Kinetic Core. We can really think of it like a biological system, a brain and a nervous system for a machine. It's all broken down into a few key layers that have to work together perfectly to bring the robot to life.
So it all starts with state estimation. This is the part that's constantly asking, okay, where am I in the world, and am I about to fall over? Then you've got the locomotion layer that takes over all movement, walking, driving, you name it. At the exact same time, the perception layer is processing all the sensor data to build a picture of the world around it. And finally, the cognition layer acts like the CEO. It takes all that information and makes the final call on what to do next. It's a complete thinking system.
And that whole thought process follows this classic, really powerful model called the OODA loop. The robot is constantly running this cycle. It observes the world with its sensors, it orients itself by building a sort of mental map, it decides on the best action, and then it acts. And this isn't a one-and-done deal. This loop is running over and over and over, which is what lets the robot react so intelligently to a world that's always changing. But look, having a solid foundation is just the starting line. The next step was to give the Kinetic Core a massive upgrade with some truly cutting-edge academic research. Specifically, they pulled in some amazing breakthroughs from the Autonomous Systems Lab at ETH Zurich. And this is where things get really smart.
And this integration led to a huge wow moment. The system achieved a massive 23 to 42% reduction in wheel slip. Now, what does that actually mean? It means the robot has way better traction, it wastes less energy, and it can stay in control on really tricky surfaces, all because it's being smarter about how it puts power down to its wheels. This research basically gave the robot a whole new set of superpowers. Seriously. With unsupervised self-calibration, the robot literally learns about its own body without a human having to tune anything. The enhanced traction gives it a grip like a mountain goat. Continuous time estimation lets it perfectly sync up data from all its different sensors, even if they're all reporting at different speeds. And, of course, it knows the instant a wheel starts to slip. It's a huge leap forward in making these things truly autonomous. Okay, so all this sophisticated software is amazing, but what does it actually look like in the real world? Let's see how this one brain can be used to create creatures that are completely different from one another.
This is where you can see just how versatile this platform is. The exact same Kinetic Core software is powering 3 totally different machines. You've got a quiet, expressive pet companion, a rugged, all-terrain mini-scout, and a modular research platform designed for experiments. The brain is identical in all 3, but the body and the personality it powers are completely unique.
So let's bring this all home. When you put it all together, what can a robot with this kind of brain actually do? What are the real-world abilities that come out of this mix of solid architecture and high-level research?
Well, for starters, it can automatically discover its own parts when you plug them in. It can calibrate itself without any manual tuning. It can feel and fix wheel slip the moment it happens. It can switch from wheels to legs on the fly, keep its balance with some really advanced predictive control, navigate all on its own, and even figure out how to get up after it falls down. The key thing here is that this isn't just a remote-controlled toy. It's a truly autonomous system. And maybe the most stunning part is just the speed. This quote says it all. From zero to a complete research-grade robotics platform built in one session. I mean, that's what happens when you have a powerful universal core. It can accelerate development from something that takes months or years down to a single afternoon. Which leaves us with a final, really fascinating question to think about. If a universal robot mind becomes a solved problem, a foundational tool that anybody can use, it changes everything. Creators won't be stuck on the how anymore. They can focus entirely on the what. So, when the mind is taken care of, what kind of incredible new creatures will we all dream up next?